In notes number 3, we are going to use our trig again to find our missing angle. And to find angle measurements, one thing you're going to have to remember is that you need to use the inverse function of sine, cosine, and tangent instead of just the regular tangent, sine, and cosine buttons. So if you look at your calculator, it's going to look like this, and it's in blue if you've got one of the newer calculators. So you have to hit your second button first, and then hit the tangent, and then this little tangent to the -1 is going to show up. And then after that, we would type in a number, and that would give us what the measure of angle A is. So that we have to use that only when we're trying to find the angle measure, and that's the big thing you have to use in this set of notes. All right, so for number 1, you're just going to practice typing it into the calculator. So we are trying to find angle A, and we need to label everything in accordance with angle A. So we have opposite and we have adjacent. So we're going to be using tangent of our angle, which we do not know the angle, so we just leave it as A. Opposite over adjacent, so 15 over 20. Now to find the angle A, I need to type in the calculator the inverse of tangent and then my whole fraction. So make sure you close off your parentheses as well. So this is what you're going to type into the calculator. And when we get that angle A equals 36.869899765, but we want to the 10th of the degree. So remember, that's one number after your decimal place. So we would put that as 36.9 degrees for our angle A. In number 2, we're going to use the same picture, so I just redrew it again. And this time we want to find out what angle C is. So we have to label it based off of angle C. And we have opposite again and adjacent, but notice they're labeled differently on the sides of the triangle because it's based off of angle C. And I want you to set this one up and solve for your angle C. You should have noticed we need to use tangent again, so tangent of your angle, which is C, your opposite over hypotenuse. So when you type this in the calculator, your angle C is going to equal your inverse of tangent, and then 20 over 15 is what you'll type in. So that gives you that your angle C came out as 53.13. So when we round it, we got to cut it off after the first number, and we'll get 53.1 degrees for our measure of angle C. Number 3, I want you to figure out if we need to use sine, cosine, or tangent based off of our angle X. So remember, label your sides and then figure out what type of trig we need to use. Based on angle X, we have our opposite and we have a hypotenuse. So the only one that uses opposite and hypotenuse is the sine of your angle. So that's the one you should have chosen. So when we have opposite over hypotenuse, let's go ahead and fill that in. So sine of our angle, which is our X, opposite is 2 in our picture, and the hypotenuse is a 30. So when you type in your calculator, you have to type in the inverse of sine, and it's 2 over 30. And now I want you to tell me, what does that equal? When you type it in, you get 3.82255. So when you round that, it has to be after the 8. So you'd put 3.8. And we are finding the degrees of our angle. So we have 3.8 degrees. This next question on number 4, you need to draw your picture first, and then you need to solve for the missing angle. And it's a ramp for a handicapped accessible house. So let's go ahead and draw a ramp. So my door is way up here to get into the house. And it is 35 feet long, so the ramp is 35 feet long. So think of, if someone tells you how long the ramp is, they're talking about the part that you would actually roll on. So that would be our hypotenuse, would be 35 feet. It's 3 feet off the ground, so that would be your direct height, would be 3 feet. And we need to find the angle the ramp makes with the ground. So that's way over here, and that's what our angle is going to be set up as. Now when we label our sides, it's based off of that angle X. So we have opposite is our 3 feet, and we have hypotenuse is our 35. So the only thing that uses opposite and hypotenuse is sine again. So we have sine of our angle, which is X, opposite over hypotenuse, so 3 over 35, And when we type in the calculator, we need to type in the inverse of sine. And then it's 3 over 35. When we type this in, that gives us x equals 4.917. So if we need to round it, we're going to round it still to the 10th place for your degrees. So we get 4 points. We need to look at the number right after the 9, and it's a 1, so it's going to stay a 9. And then degrees, so 4.9 degrees. Number 5, we're going to try this in these set of notes, but on the next set of notes, we're going to focus solely on questions like number 5, where we need to find all the missing angles and all the missing sides. And how we would do that is when we look at our picture, the easiest thing to find probably is the other angle, so angle B. So I'm going to label this as an X. This side is Y, and this side is Z. So if I just label all of them first, then I know when I find it of where that shows up in my picture. If I want the missing angle, I know that 42 plus the 90 degrees in the corner already, plus my X has to equal 180 degrees because I've got a triangle. So 42 plus 90 is 132, but when I subtract that from 180, I end up with a 48 degrees. So the measure of angle B is 48 degrees. So there's one piece. Next, we need to find our Y or the Z, and it's up to you of what you want to find first. When we label this, our Y is our opposite, 70 is adjacent, and then my Z is my hypotenuse. So if I want to find the Y first, I need to use the Y, and I have to use the side that gave me a number. So I have adjacent, and I have opposite, so that it would be tangent. So tangent of the 42 degrees is my opposite over adjacent. So Y over 70. Remember, we need to put it over 1 so we can cross multiply. So I end up with 1Y, or just my Y, equals 70 times the tangent of 40. So if we multiply those pieces together, that gives us a 63.028. And if we round that, we would cut it off after the 0, but it's a 2, so it's going to stay a 0.0. And that is my side Y, which is CB. So CB is 63.0. Lastly, for my third side, I could do two different things. We could use Pythagorean theorem to find what my hypotenuse is, now that we know what two of the sides are. Or I could set up another trig equation, and that would be my hypotenuse, and I have to use my 70, so adjacent. So we have adjacent and hypotenuse, and that would be cosine of my 42 degrees. So adjacent over the hypotenuse. When I put it over 1, then I can cross multiply. So I get Z times cosine of 42, and that equals 70. But remember, I need to divide by the cosine of 42. So my Z is going to be 70 divided by the cosine of 42. And if I type that all in the calculator at the same time, it makes it a little bit easier. So I ended up with 94.194. We got to cut it off after the 1, and because it's a 9, we do need to bump it up to a 2. So this would be 94.2. This is with a hypotenuse, so we've got feet for our length, and the side would be AB. Now remember, if you got a little lost in that number 5, it's just to go through and find out what all your missing sides and angles are instead of just one in particular. So we're going to spend more time on that on the next video on number 4, but this is just a little taste of what that could be. On number 6 and number 7, this is just in the calculator, and if we are given that the sine of A equals this decimal number, we know that if we want to find the angle A, we have to take the inverse of sine. So I have to take the inverse of sine of 0.87, and if we type that in a calculator, that gives us a 60.4586. In our directions, it says to round to the nearest tenth of a degree, so that would be 60.5. And the reason it's a 5 is because our number right after the 4 is a 5, so we need to bump up the previous number. So 60.5 degrees. I want you now to do number 7 for the cosine of B. So in your calculator, you should be typing in the inverse of cosine of 0.15. When you get that, you should have gotten 81.373 around. So when we look at the 3, the number after it is a 7, so we do need to bump it up. This would be 81.4 degrees for your angle B. Number 8, we are going to see more of the application questions in our notes number 5. But again, I want you to practice setting up the picture now because we can use it now to solve our different questions. So on this one, we need to draw our picture. We've done this one similar like this before with our special right triangle, so that's why I pulled this one up. An airplane pilot is taking off on the runway, and he needs to reach a cruising altitude of 10,000 feet. So that means direct height would be 10,000 feet, so that'd be straight up and down. He flies for 3,000 feet through the air, so it's not the ground distance. So that would be our hypotenuse, the actual space that the distance that the plane actually flew in the air is 30,000 feet. And we need to figure out what angle he took off at. So remember, that's the angle of elevation. And now we can label our sides. We've got opposite, and we have hypotenuse. So which trig function uses opposite and hypotenuse? You should have chosen that it is the sine of our angle, and that would be our opposite over hypotenuse. So when we set up the pieces we've got, that means we've got the sine of our angle, so our x. Opposite should be 10,000 feet. Hypotenuse then is our 30,000 feet. And we need to look at the piece we're trying to find. We are trying to find the angle. So because we need to find the angle, we have to do the inverse of sine. So we're typing in the inverse of sine of 10,000 divided by 30,000. And when we get that in our calculator, we get 19.471. We need to look after the 7. It is, or after the 4, sorry. It is a number bigger than 5, so we got to bump up that to now it's a 19.5. And this is the degrees of the angle he took off at.